Subtract 4 from what? From 3. So we want to do 3 minus 4, and then what? And then add 8. And what is 3 minus 4 plus 8? 7. So we get, well, wait. This equals 7. Therefore, this is e to the 7th now. Simplified. Okay? Make sense? No, yeah. What'd you say? Skills check. No, the skills check is actually going to be on Monday. Just so you guys know. Okay. Sorry. Just because there are some scheduling things to talk about at the end that have to be moved around. So, yeah. All right, number 2, simplify this expression. 18 divided by 6. What do you get? 3. And then e to the 7th over e to the 3rd. E to the 4th. Okay. All right, and then is the table an example of an exponential growth or exponential decay? First, before we answer that question, how can you check? Or how do you know? It's greater than 1. Yes, but that's for the function, remember? That's if we're given a function. In this case, we're just given a table, right? So how can you know from a table whether or not it's exponential growth or decay? What if you plotted the points, maybe? Yeah? So if I made a graph, I know that 1/6 would be like here, and then 2/36 would be like here, and then 3/216 would be like here, and then 4/1296 would be like way up here, right? So my graph, all we know are these points, right? They look like that, right? What do you think? Remember when we had the bacteria problem last Tuesday? It's the very first day of this unit. When we said you're growing by 2 times, right? What are you growing by from each point to the next point? So from here to here, what do you grow by? Times 6. Or, yeah, you grow by 30, but times 6 is the same thing. And then from 36 to 216, what's 216 divided by 36? 6. So that's multiplied by 6. What about here? 6. So, if you think about it, that means, and when we're plugging in x, we know it's going to be in our exponent. What does our function look like? What does f of x look like? Do you guys have a guess? What'd you say? F of x equals 6 to the what? What does our exponentials always look like? Not just to the second. We're plugging in our x, right? And 6 to the first is going to get us 6, right? 6 squared going to get us 36, right? If you plug in 6 cubed, what are you going to get? You guys got calculators for a reason. You're going to get 216. So do you notice a pattern? This equation would look like 6 to the x. So the easy way to tell whether or not it's growth or decay with just the table, though, well, is this growth or decay? Growth, it's growth. But the way to tell with just looking at a table is as x goes towards infinity. So here, x is growing, right? You go 1 to 2 to 3 to 4. That's growing positively, right? So as x goes towards infinity, f of x is going towards what? Is it going towards negative numbers or positive numbers? Bigger positive numbers, right? So as f of x is going, or as x is going towards infinity, f of x is going towards infinity. And do you remember that when we talked about the end behavior of an exponential growth function, they look like this, right? That's a really bad graph. But their end behavior said as x is approaching infinity, f of x is approaching infinity. Okay? Is this making sense at all? Okay. All right. Open up your workbooks to page 373. Today we're just going over a continuation of our compound interest. This one, though, is a little bit of a new idea. It's just a different formula, which you will be given on your test. But the cool thing about it is that we get to use E now. So make sure you go grab a calculator, please. So we really need you to have calculators for this, okay? And then make sure you turn your bell work in so you can get points for your bell work this week. So page 273. We're back in 7 dash, or not 7 dash. Yeah, we're back in 7-3, okay? So if you don't have a calculator, please go grab a calculator. Because you're gonna need a calculator. So if you need to grab a calculator that's on a desk near you, do that. And then make sure you turn in your bell work. Okay. So on page 373, right above example 1, it gives us this little explanation. It says, you can calculate continuously compounding interest by using the formula A equals PE to the RT. We call this lovely formula PERT. That's what we call it, because PERT is PERT. That's the name, okay? Does that make sense? This is our PERT formula, where A is the amount in the account after T years, P is the principal amount invested, and R is the annual interest rate. Does this stuff look familiar? Right? Yes, it should. These variables are the exact same type of variables that you had in your other compound interest formula, right? The only difference is you have a little bit of a different formula and you're going to use E, which is why we need calculators, because you really can't calculate E on your own, okay? You can't calculate E using your own brain power. I can't either, okay? So, yeah, P is your principal. E is always going to be the, that could have been so bad. Here's my copy. E is always going to be the idea of E, 2.7, blah, 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 remember the number? But again, that's why we use our calculator, because we don't actually know the, are they actually glass?
Yes.
Well, that is impressive. I'm not going to put that
I
on.
was gonna say, don't put it on the second one. Second one's too tilted.
Okay, so we're going to practice using this formula, except that, per usual, they plug everything in for us, but I want you guys to plug it in your actual calculator. So, real quick, Lashandra deposits $1,500 in a savings account that pays 2.5% annual interest compounded continuously. After 4 years, what will be the balance of Lashandra's account? What is our principal? Yep, $1,500. What is our rate? Yep, it comes from 2.5, which means that R is going to equal 0.025. Remember, always moving the decimal 2 times to the left. And what's our T? 4. All right. you can see that they've plugged all these pieces into this equation right here. Okay? Make sense? All right. We're going to go plug it in our calculator. So, we're going to know that we have to use the PERT formula when it says we are compounding continuously. Okay? Compounding continuously. That's when we know that we have to use the PERT formula. All right, I'm gonna exit out of this. Do you mind pulling up the calculator? Thank you. I'm gonna exit out of this real quick so I can use the calculator.
Your shortcut disappears and all that. Nope, hang on. It's gonna take a minute.
You're good. So, actually, did anyone actually go turn their bell work in? I just remembered. If you went and turned your bell work in, can you go grab it, please? Or I can pass back out to you. Because there's that, on that last problem, on the end, there's that compounding continuously problem. And we're gonna go over that together on how to do it with our PERT formula. Okay, thank you. What's our principal? 1,500, so we type in 1,500. And then we type in E. So E is going to be seconds. You click the second button, and then you click your natural log button. That's what this ln button is. And it has E to the x above it, okay? It's the third button down in the first row, or first column, sorry. Third button down, first column. And then in the exponent, we're going to type our rate and our time, which is 0.025, and then you can put it in parentheses or you can multiply it. They're doing the same exact thing, times 4, right? So, what did you guys get? Yes, 1,657.76. All right? Per usual, we're going to try and we're going to always round to 2, especially since we're dealing with money in this problem. We're going to round to the nearest hundredth, right? So 1,657.76 Yep. All right. So after 4 years, LaShondra will have $1,657.76 in her savings account. Okay? So this number just goes here. Making sense? Cool. Okay, we're going to do the check together because I'm actually going to have you guys try and do the bell work one on your own. And then we'll go over the bell work one together so you guys do get a practice with this. So the check is right underneath that example 3 that we were just on. It says Alejandro invested $4,500 in the startup company. His investment has been growing continuously. Keyword. This is when we know we use the PERT formula. Okay. At an annual rate of 12.5%. So write the function that represents the situation where f of x is the value of the investment in after t years. So when it says write the function, we're going to plug in some of our points or our numbers that we have, but we're not going to have all the numbers because we're just going to write the function, okay? We're not actually solving for anything when it asks us to write the function. Does that make sense? I will say this is something that will be on your test. It's going to ask you to write the function rule, okay? So, and we're going to work more with that next week too, during review days. So it says that we want where f of x is the value of his investment after t years. So what are we going to start our equation with? A equals. Not instead of a equals. What's this say right here? What are we replacing a with? F of x. We're replacing a with f of x in this equation. Does that make sense? And then, what's our principal? 4,500. What's the next part of the equation? E. And then to the what? Yep, 0.125 t. Does that make sense? I will say that when it asks you to write the function rule, instead of writing f of x, you're going to typically be writing a, just because that's what the equation usually uses. Does that make sense? In this instance, it's asking us to plug in f of x. Okay. So, this is what it means to write the function rule. We have two variables that we don't know technically, so we can't solve this, okay? So, part B asks us to evaluate the function. So this is going to give us one of these values to plug in, okay? So it says after 5 years, it continues to grow in this way. Alejandro's investment will be worth how much? So what variable are we given? 5 for what? T. There we go. So we're going to plug in 4,500 e to the 0.125 times 5. Okay? And what do you guys get? 8,407.11. Okay? Is this making sense? You're feeling okay about this? Everyone's remembering where the E button is on the calculator, correct? And then after 12 years, how much will it be worth? So where does 12 go in the equation? T. So what do you guys get for 12 years? 60 cents. Awesome. Yep. All right. So what is the difference between what we learned on Tuesday and today? Yeah, Joshua. The formula. And how do we know to use the formula we learned today? Yeah. When it says continuous. Okay? So continuously compounding, or compounding continuously is actually how it's going to be phrased. Okay? Compounding continuously is when you know to use this formula, the PERT formula. All right. So I mean, we got plenty of time. You guys can actually do this as your check. So I want you guys to do this on your own. So it's going to ask you to write the function rule, and then it's going to be ask you to write for after 18 years. And then also answer this. What if it was compounded monthly instead of continuously? We're going to go over it. This is number 14 in your practice problems. So it's on page 377. So if you want to do it by number 14, you can. Or if you want to do it on your notes sections on the sides, feel free. So I'm going to give you guys about 5 minutes to answer all these questions, okay? Is everyone good on this one? Okay. It says Jiraiya invested $6,500 in a savings account that grows continuously at an annual rate of 3.25%. So write the function rule that represents the situation, and then where f of x is the value of Jiraiya's investment after t years. So what does our function rule look like? Yep. A equals, should I have 5,000?
Oh, 6,500.
There we go. 6,500 e to the 325 times t. Okay? So biggest thing, r equals 0.0325. I think that's something that a lot of us, including all of the other Algebra 2 classes, have really been struggling on. We always move it 2 times to the left, okay, from our percentage to get our decimal. Sound good? Okay. And then B asks us to plug in what for what? 18 years for what? T. So you get $6,500 e to the 0.0325 times 18. And what do you get? 0.44. Good. Is that making sense? Okay. And then if it asks us, what if it was compounded monthly instead of continuously, what are we going to change? Not just t. Compounded monthly uses what equation?
Compounded monthly uses 12, right?
Month. Yes, it does use 12 for what? For the t, but we have to change equations. We have to use the a equals, and then it's...
For the end.
Oh,
Not
yeah,
the
it's
T.
for the end. The
Oh,
T-
yeah,
Like,
thank you.
both said T. I can tell you both were thinking N.
Yes, we're thinking n. 6,500, and then it's the 1 plus our r over n, which is 0.0325. Yep. 325 over our n, which is 12, because it's compounded monthly, to the n times t, which n is 12. What is t? We're just going to assume that we're still thinking 18 years for t. Yeah. Okay, so 12 times 18. So, using this formula, what do you get? Mm-hmm. 11,658 and 22 cents. So my question for you is, would Jiraiya prefer for it to be compounded continuously or compounded monthly? Which one? Continuously. Because do you agree that this number is bigger than that number? Yeah. Only by like $12 though. So after 18 years, if the difference is $12, really not that big of a deal, right? But of course, $12 in interest, that takes a long time to build up. So, honestly, I would just he would rather it to be compounded continuously. Make sense? Okay. Everyone feeling okay about this? So I'm going to challenge you guys to go through your bell work for the last few minutes. Go through your bell work on, it says, I need to pull it up again. Let me 1 second. I should be able to.
In that folder.
Yep. Algebra 2. What day did we do that? We did that. Oh, here we go. There we go. What is happening? What is happening? There we go. Okay. So at the bottom, it says, suppose Laura invests $4,800 in an account after earning 4.5% interest. How much money does she have after 20 years? And then I want you guys to do part D. Okay? Just compounding continuously. So once you finish part D, go ahead and turn it in. And then, yeah. Yes, formulas will be on the test. So once you've all turned in your bell work, we'll go over what the schedule is going to look next week. Oh, I didn't actually calculate it. Sorry. What'd you get? Yep. Alright, so what I just passed out to you guys is your progress report up until, what day is your, 2 days ago?
Wednesday morning.
Wednesday morning. On the bottom, underneath the blue highlighted, it says that is what you're missing, okay? That's all the work that you're missing. So if you want a chance to retake your Module 6 test eventually, and you're missing things for Chapter 6, you need to get that stuff turned in. And then, same thing for Chapter 7 tests, once we take it next week. If you guys don't feel too hot about it, too great about it after next Friday, and want a chance to retake it, you're gonna need to make sure that all that Chapter 7 stuff is turned in. Any pre-tests missing or bell work missing, those are easy points to turn back in, okay? So get those turned in as well. Next week, so we told you the test was supposed to be Thursday. We found out yesterday we have a convocation next Thursday. So we have a shortened time period, about it's like 30 minutes per class. So we're not doing tests next Thursday because we want you guys to have full time on it. So tests will be next Friday. So Thursday will just be another review day. What we're gonna do is skills check. We're gonna do on Monday at the very beginning of the period, okay? And then after skills check, we'll go over the last skills check we had because all I did was have you guys correct it and we never actually went over it. So you guys should have that back. If you don't have it back, let me know because then we have it. And so make sure you have that with you on Monday. Tuesday, we're gonna do a problem trail. So let's just review for the test. It'll have questions just like you're gonna be on the test. Okay? Study guide is on campus.
No, we will have a physical review. I don't have it printed yet.
What's it?
And there will be one on Alex. So if you want to start working on it this weekend, I'll put it together on Alex.
Tuesday will be problem trail, and then if we finish early, you have time to work on your study guide, review, the Alex, whatever you need to. Wednesday, the focus is going to be on Wednesday to do any makeup work. So get any skills tests or tests that you've missed. Get working on those. Any homework that's not turned in, get working on those. And then Thursday is going to be continuing review, okay? Thursday will be more trying to get questions answered, make sure everyone's feeling comfortable for Friday, okay? So test a week from today. Sound good? Sorry to change it up on you. I apologize, but we also just found out. So get your bell work turned in. And that's everything. So good job today. Yeah. Are we allowed to tell them what equations are going to be on the test?
Oh, yeah. Well, I'm going to
Okay.
write the formulas up on the
Oh.
whiteboard next week because everything's going to get erased today.
Yeah. So just so you guys know, the formulas that are going to be on the test, both compound interest formulas, so the one we learned today and the one we learned Tuesday, your standard form for our exponential equation, so a to the bx minus h plus k, that will be on there. There's one more, isn't there? B to the x,
B
right?
to the X.
Yeah.
Which is
Which is the same thing. So make sure you know what variable means what, but you will be given this formula, okay? So yeah, that's everything we have for today. You guys have like 10 more minutes, so if you guys want to work on homework, get started with that. I zoomed in. Everything's really large.